right? So as I was saying, if you miss one lecture or something like that, that's okay. But I'd rather you come every Friday. It's just one day of the week, and it's an opportunity to look at some of the stuff we've been reading or lecturing on, ask questions. And also one thing that I certainly should say, and I think this happens to everyone who's an instructor or everyone who's a professor, we notice people who participate in discussions. I mean, obviously, my intent is never to. My intent is to always help out people who are just, students. I don't. Um, but I should say that if someone is like participating constantly, giving me feedback, showing that they've done the readings, that definitely counts in cases where I might be thinking of whether I should give them a higher grade. So I'm not going to punish people for not participating, but I'm going to reward those who for not participating in the live discussions. But I'm definitely going to reward those who do. And I know so, and this is another thing, important thing, which is that I know that some people are shy about talking in public. So you can also participate through the chat. You can ask. You don't necessarily have to make an objection or make a point. You can ask a question, a clarificatory question, something like that. And I'll start noticing you. I mean, obviously, it's not easy to remember everyone you meet during their first time. But for example, I noticed that there are people who are here from my last class. I'm glad to see you again. Um, Last semester. So yeah, and I notice people, and I can see whether people are putting some effort into the work, right? Um, what else? Yeah, the stuff that I mentioned that well, this is a 100 level class, so um, and it's only 3 months, so there's not going to be a chance to cover that much. But I do think that we can start at least giving a sort of introduction to some very interesting subjects that have to do with not only rationality, but also the practical stuff broadly understood. And as I mentioned in my video lecture, I think that when people are navigating the world these days, I mean, there's a lot of information that people have to come to grips with. So obviously political information, what's going on, in their communities, what's going on in their countries, in the world, etc. Uh, Navigating their work and academic environments and their personal relationships. So uh, just being able to think and write, in a very, I guess, in a clear manner and in an articulate manner, that already starts helping people to navigate those spaces efficiently. In fact, there's some research that shows that one of the best things that people can do to improve their ability to understand concepts, to do better in school, to do better in their work, one of the best things that they can do is just write more. Why? Because one of the things that writing does is it lets you put together your thoughts in a manner that other people can understand it, right? So we are all the time in our own heads. And whenever we are in our own heads, or it's very easy for us to, I guess, or sometimes it's easy for us to understand ourselves better than other people understand us. Um, but it's very typical that we think that something is very obvious or very intuitive, and whenever we are writing that down for someone else, for example, in a paper, in an email, even in a text message, there, a lot of confusion ensues. Maybe you've been in a class where a professor gave you a grade that you didn't think you deserved because they didn't understand what you were trying to say. But part of the issue there is that um, people come to stuff with different assumptions. For example, when for the, to a chapter or to an essay or something like that, or to a conversation. So one of the things that practical reasoning is about is logic. One of the things that logic helps you do is um, have a superstructure of your thoughts and ideas, and see how they are related to each other, how one idea follows from another or connects with another, and that helps people be better writers and better speakers and better thinkers generally. So that's one thing. I mean, that's like I guess the practical application of logic. But logic is also at the forefront of a lot of interesting research and applications in artificial intelligence, computer science, foundations of mathematics, etc. Right? So I mean, obviously, we're not going to get into any of that stuff. But one of the things that I do want to do, and I think it's interesting to do, is to try to show people who might not be familiar with that stuff why other people are passionate about that stuff. So I'm certainly passionate about most of the stuff I'm going to be talking to you about. And I mean, obviously, people have different interests, so I don't expect anyone to share my passions. But I do expect people to at least see why anyone could be passionate about that, right? So, and that's what an introductory course is for, partly, right? So it gives you like the groundwork, it gives you the foundations. But still, some of the stuff that we're going to be looking at, in spite of all of that, in spite of the fact that it can be very interesting, it's very dry at the beginning. So, for example, we're going to start looking at stuff on arguments. So, like, what's an argument, how arguments are structured, etc. And then in the beginning, it's sort of dry, sort of a little bit boring, I guess. But my hope is that once you see the big picture, you are going to see how that connects to other, more interesting, more groundbreaking ideas or theories, etc. So, and in connection to that, I also wanted to mention like some of the other stuff that we're going to be covering. So one is logic. Another thing is just like very, very core notions about probability. Nothing like no mathematically heavy applications. Just like what are the basic concepts and how they work, and how how probability enters into knowledge, reasoning. Also models, scientific models. So one of the things that people want to try to reason about when they are, when they are reading the news, or when they are navigating the world, is scientists are producing research all the time, or new technology, etc. So how do they do that, right? So how do scientists reason in order to be able to create models that help them predict the world and understand the world? So I'm going to be discussing a little bit of philosophy of science. What's the nature of models? What's the nature of scientific representation? In very, very broad ways, very introductory. And also some stuff having to do with philosophy of rationality, decision theory. So maybe some of you have heard about the prisoner's dilemma, for example. So for example, a decision, when understood in theoretical terms, it's it involves sort of outcome matrix. So you have a series of possible actions that you can perform, and then you are aware of some of the possible outcomes and their payoffs. So what will happen if I did this? What will happen if I did that? And then part of what decision theory tries to do, which is a sort of branch of math as well, and logic, is it gives you like methods, formal methods, rigorous methods to decide if you're in a sort of dilemma where you know what are the possible outcomes, what to do, or what's the sort of best decision to make. And then in connection to that, decision theory, for example, is just like decision procedures for agents, for individual people. So how can individual people reason about specific outcomes in order to maximize what's going to happen after they decide? So those are called one-player games. But then we go into game theories, which is like an n-player game with more than 2 players. And then in those cases, we might also want to say something about that. So I might discuss that a little bit. But again, as I mentioned, nothing mathematically very heavy or anything like that. It's mostly conceptual stuff. And the questions will be on the concepts, right? Mostly on the concepts. So any questions on that? Okay. So let me start out by saying something about arguments. So can you see that handout, arguments and their basics? Yep.
Yeah.
Yep.
Okay, so sorry about my dog. So the idea here is that an argument is just going to be a series of statements, but unlike some random collection of statements, an argument is supposed to be a series of statements that are going to help you support a conclusion, right? So, I mean, arguments can be written in any sort of form. So you can have a paragraph, for example, where someone is saying something like, well, you know, if the government interferes with people's liberties, then it deprives them of their autonomy, and autonomy is the most fundamental value, right? So therefore, the government should interfere in people's liberties, right? So you'll see arguments like that in the newspaper, in the media all the time. Sometimes many of those arguments are not like completely rigorous, but you can see that there are a number of sentences or claims that people are making, and that those claims are meant to support another claim. So they are meant to provide evidence for other claim. So if we try to analyze what it means to give an argument, the first step that we're going to notice is that these claims, which are sentences basically, that there are a number of them, right? So these are called the premises of the argument. And these are the things that people say in support of their views or in support of their conclusions, right? So, those are going to be premises of the argument. And then the conclusion is just going to be another sentence or claim that the premises of the argument are supporting. And then what we say in those cases is that the premises of the argument lend evidential support to the conclusion, right? So if you have an argument, then the premises of that argument are trying to give reasons for accepting the conclusion. So that's the first thing to notice about arguments. And I guess, for example, one way of easily identifying a conclusion, the premises and the conclusion is, for example, you're going to see that some premises say, an argument starts out by saying something like, if this happens, then that happens. Or suppose this were to happen, then etc., right? Or this and that are true, for example. If it's true that I'm teaching on Friday in the morning, and if it's true that you need to go there to get some participation, then if you want to get some participation, you should go there, for example, right? So that's a sort of argument, right? And then you can see that the premises of the argument have this structure where you say, you make these conditional claims, if this, then that, or this is the case. If this is the case, then if this is not the case, then we should not do this, etc., right? So conditional claims and then categorical claims supporting those conditional claims, right? And then conclusions of arguments usually begin with thus, therefore, it follows, etc., right? But that's more or less how you are going to be able to identify arguments in a general way. And then there's this distinction between arguments. There are arguments which are called deductive, and arguments which are called deductive are arguments that have the intent of providing the strongest possible support to the conclusion. That's the idea of deduction, right? The idea of deduction is, if I have a series, for example, if I have a set of information, then from that information or those arguments, I can conclude, if the argument is any good, I can conclude without any question the conclusion, for example, right? So, so suppose I tell you that it's either Monday or Tuesday. Premise 1, it's either Monday or Tuesday. Premise 2, it's not Tuesday. What can you conclude?
That today is Monday.
Right. I mean, that's a very trivial case. But if you notice that case, it has two premises. It is either Monday or Tuesday. And then that's the first premise. And the second premise is it's not Tuesday. So that's all the information you have. But it's very intuitive to see that if that's true, if it's either Monday or Tuesday, if that is true, and it's true that it's not Tuesday, then it's going to follow that it's Monday. So, I mean, we all have this. So logic is, in a sense, sort of basic, some very basic logic abilities are sort of hardwired in everyone's brain. But part of what logic does when it's studied in a more systematic manner is that it tries to regiment and give you like algorithms or decision procedures or methods which are systematic and rigorous for going from premises or a lot of information to the conclusion. So what that means is that the same process that you perform when you are deducing the conclusion of the argument I just gave, that it is either Monday or Tuesday, but it's not Tuesday. That same process, once you internalize some of these procedures, you can apply it to chains of reasoning, which are very, very complicated. So, for example, here's a claim that that I'm going to discuss later on, maybe with more substantive examples, but which I think is an illustrative claim, which is there have been some philosophers which have defended the view that mathematics is just it's nothing other than logic. So arithmetic, calculus, even topology, etc. It's just a series of very complicated abstract structures dealing with all sorts of either geometric objects or numbers or etc. But then the intuition that these philosophers had is that once you analyze what mathematics really is all about, what you find out is that it's really just the very fundamental axioms and laws of logic, and that many of the important truths about mathematics can be got from that. So that's a philosophically controversial claim. It's not something that has been established, but there are good reasons for that claim, right? And the reasons for that claim is that actually there are logical systems, like just purely logical systems, written down in what is called symbolic logic or mathematical logic, where you can show or deduce the properties of many branches of mathematics, the natural numbers, the real numbers, etc. Right? So I guess part of part of my point of saying that is just that these very basic deductive structures can be extremely powerful once you develop them, but they look very trivial when you look at very basic cases. But anyway, that's the idea of a deductive argument, right? And then one thing that I mentioned, which is important to clarify, and let me just do this. So one thing I mentioned, which I think is useful to clarify, is that we have the deduction, and then so as I mentioned, when I mentioned deduction, one of the things that I said was that deduction had to do with what's the intent of the argument. So what are people who give deductive arguments trying to do? And part of what they are trying to do when they give deductive arguments is to guarantee that they try to guarantee that if the premises are true, then the conclusion is true. So that's one thing that people who give deductive arguments are trying to do. Just make arguments that are categorically solid in the sense that if you have certain premises that are true, then they are going to guarantee a certain conclusions. But for all that, deductive arguments might fail. They might be bad deductive arguments. So you can give a deductive argument, and it can turn out to be a bad argument. That's the point that's the point I'm trying to make, that the fact that you're making a deductive argument does not guarantee that the argument is any good. So consider, for example, the argument we just heard. So this is a good deductive argument. Because in this argument, if the premises are true, then that guarantees the conclusion, okay? And these arguments, the good deductive arguments, like this one, these arguments are called valid arguments, right? And then let me give you a bad deductive argument. So just an intuition. What's going on with this argument? What's the problem?
The Saturday part.
In what sense?
If you're saying that it's not Tuesday, you still leave the possibility of it being Monday or Saturday open, so you can't logically assume that it's Monday because you haven't eliminated the possibility of it being Saturday.
Right. Yeah, I mean, I think that both responses help with this. So on the one hand, we have more information in premise one than in this other argument than in the first one. It gives us three possibilities, right? So in the first argument, we had ruled out one of those two possibilities, so there wasn't any other alternative. However, the information we have here in this argument does not suffice to rule out the other possibility. So when you get to the conclusion, therefore it is Monday, we have not guaranteed that the conclusion actually follows from the premises. So, and this is a very important concept. I mean, I guess many people have heard this concept, but it's not, I guess it's not used so much in daily life. Maybe, you know, maybe by a pedant or something like that, but not that much. But the concept of to follow from something, right? It follows that, etc. And then the idea of saying that something follows from something is that in deduction is just that if you have the premises of an argument and they are all true, then if that's a good argument, you know, if you say that, for example, you have the premises of an argument and you say that the conclusion C follows from those premises, for the conclusion C to actually follow, it must mean that the premise that the argument rules out any other possibility, right? So one way of understanding this idea is to say that it's just to give a definition of validity. So this is a very important definition. And this is unlike the definition of deductive, which I just gave you. So if you remember, if you recall, part of what I said was that in that definition, the definition of deductive, part of what it means for an argument to be deductive involves the speaker or the user of the argument, what they intend to do, what are their intentions, right? So it's a sort of rhetorical definition, right? So an argument is deductive if the intent of the person using the argument is to establish the conclusion from certain premises, to guarantee the conclusion from certain premises. But as I've said, there are both good and bad deductive arguments. And then this property that good deductive arguments have, this property, that's an objective property of arguments. That's called validity. So it's a specific use of the notion of validity. It's not the typical notion of validity. It doesn't mean valid as it's okay or it's acceptable. No, it has a very technical, precise term. And then what we're going to say is that a deductive argument is valid if and only if it's not possible for the premises to be true and the conclusion false. And then a bad deductive argument is then just going to be invalid. And so what is that going to mean? What that's going to mean is that it's going to be possible for the premises of an invalid argument to be true and the conclusion false. So so this is an example of a valid argument, the first one. And this is an example of an invalid argument, right? So let me go back to the handout. Any questions so far? Right. So as I mentioned earlier, people who are trying to persuade others through reason try to use arguments. But arguments are not only important in persuasion. When you're writing, when you're talking to someone, trying to convince them to do something, where you're trying to, you're writing down, either a column or an essay or etc. Those are classic mediums of persuasion, and the classic tool for those mediums is the argument. So it's important to be able to see to identify, recognize arguments, recognize what are the premises, what are the conclusions, how the premises are trying to support the conclusion. That's a very important thing. So for example, if you ever go to grad school, you're going to have to do the GRE. And the GRE has this, this part, or to law school or whatever, has this part called the analytical reasoning part. That's just pure analysis of arguments, right? So if you know how to just analyze arguments or even read the arguments, then you should do very well in that part. So another example of, for example, maybe the sorts of exams that involve these things, for example, the reading comprehension part of the GRE. It's a part where that's the exam for going to graduate school. It's divided into parts, like the verbal thinking part and the mathematical thinking part. And a lot of people just do really badly on the verbal thinking part. Like a surprising amount of people don't do well. And one of the reasons for that is that one of the things they ask you in the exam is to reconstruct what people are saying in the, they give you a number of text, essays, letters, paragraphs. And part of what they ask you to do is to piece together what the authors of those pieces of writing are saying, how they are saying it, how they are supporting it. And then you might think that if you have been reading all your life, then it's going to be very easy to have a very high reading comprehension. But it turns out that that's not true. It turns out that obviously, the practice of reading is important on its own, and it's a necessary condition for being a good reader. But it's also necessary to be able to recognize the structure of what people are saying. So that's another important notion that has to do with arguments, just the idea of improving your reading comprehension, because part of what it means to, recognizing arguments, part of what that means is recognizing certain patterns, right? So human beings, there's some research on this, but human beings are really, really good at pattern recognition, much better than many algorithms or machines. So for example, if you compare how a human being plays chess versus how a computer plays chess, many of the typical chess playing programs, not the machine learning stuff, but many of the typical chess engines, what they do is they just compute. They just do a ton of math. They assign numbers to different plays and etc. And they do very complex computations very quickly. But humans are just not that great at computations. We can't even multiply. We can't even do multiplications very fast. We are very bad at that. But we are really, really great at pattern recognition. Navigating a city. Recognizing where you are in the university campus. being able to solve a puzzle or a maze. Even aesthetic thinking, for example, design. All of that has to do with pattern recognition. For example, recognizing some beautiful forms, etc. And recognizing arguments is partly, a matter of pattern recognition. So these properties that I was just mentioning, for example, you start out with, premises, noticing that there are some statement, the conclusion, and noticing that there are some other statements that are trying to give support to that. So that's the first step. And then you have to try to figure out whether that argument that people are putting forward, whether that argument is actually meant to be deductive, whether the authors of the argument are trying to convince you that if you accept the premises, then you must accept the conclusion. And then once you notice that, you can analyze whether the argument has this other good property, right, that we mentioned, which is validity, right? And then, as I mentioned, if an argument is valid, then it's an objective matter. Doesn't depend on the speaker or anything like that. It's an objective matter that if the premises are true, then the conclusion must be true. But part of that pattern recognition just involves internalizing these definitions. So I had just mentioned the definition of validity. Again, a deductive argument is valid if and only if it's not possible for the premises to be true and the conclusion false. But arguments also have another property, which is called soundness, right? So this is a different property. And then I guess, let me again stop sharing this and move to this other screen. So consider this classical argument, right? And then let's compare this argument to this other one. And again, that to this other one. So 3 very different arguments. If you notice, all these arguments have the same pattern that I mentioned in the beginning. They are all arguments. So I guess just for the exercise, what are the premises of those arguments? So what are the premises of this first argument, the all men are mortal argument? Just give me the numbers.
Number 1 and 2 are the premises.
Yeah, and the same for all the other 2, right? I mean, that's very obvious. So as I mentioned, the therefore here is, I guess, a very big clue. Sometimes conclusions don't have that big clue on that. But the point is, we have these 2 premises, and then they are supposedly supporting the conclusion. So they are supposedly giving us evidence to accept the conclusion, right? So that's the first thing to notice. We have premises and conclusions. Then the second thing to notice is this argument, for example, the first one, it's valid, right?
Yeah.
So here's the way to represent what that argument is saying. Okay, so suppose you have the set of men or people, the set of humans, and then you have Well, let me just use the point. You have Socrates here, Socrates, and then this is here. So these are called Venn diagrams, these things here. We are going to be using some of those. Sorry, I'm trash with the diagrams. Anyway, so part of, this set here, the set of men, part of what this diagram is illustrating is that this set here, the set of men, is a subset or is included in this larger set, the set of mortals. That's what the first premise is saying, if you notice, that everything that's a man, is also mortal, right? So this set is included in this set. That's what the first premise is saying. That's what I'm representing here. Then the argument also is saying that Socrates is here, is a member of the set of men, is included in this class. But we already know, because of the diagram illustrates this, that anything that's included in this class is included in this larger class, right? So Socrates is mortal, right? So the argument's premises were saying that all men are mortal, and Socrates is a man. And it's going to follow, because it has, like, every other possibility has been ruled out. It's going to follow that Socrates is therefore mortal. So that argument has, on the one hand, it has the property that it's valid, because it is not possible for the premises to be true and the conclusion false. But it also has another property, which is called soundness, or that the argument is sound, okay? And that property means that the premises are also true, okay? Not only, so those are two different claims. If you notice, the validity claim just says that if the premises are true, that's a conditional claim. If they were true, then the conclusion will be true. That's basically what logic is, okay? Just to put it out there just right now. Logic has to do with the connection between the premises and the conclusion in an argument, or in structures like arguments. This logical connection, what that means is that there's preservation of truth. So a good deductive argument is it's an argument that preserves truth from the premises to the conclusion. That's what a deductive argument is. But again, validity is this conditional property that if the premises are true, the conclusion must be true. It doesn't say that the premises are true. An argument can be valid even if the premises are false. It just needs to be an argument where if the premises were true, if they were true, then the conclusion will be true, right? So there's this other further property, which is called soundness. So an argument is sound if it satisfies two conditions. First, it's valid. So it's a good deductive argument. If the premises were true, the conclusion will be true. But also the premises are true. Okay, those are the best arguments we can find, because they are deductive arguments. So if they are good, they are going to guarantee the conclusion. They are valid. So we know this. We have this property that if the premises are true, the conclusion must be true. And it turns out that the premises are true also. So that means that we can be sure that the conclusion is going to be true, right? And I mean, these arguments that I'm giving here these are toy examples. Again, these are just two premises arguments, etc. But the interesting thing is that you can construct like very, very large deductive arguments, like chains of reasoning, which are extremely solid, that guarantee the conclusion. And then if you just have enough evidence that the premises are true, that's one way of getting some definitive knowledge right there. But now, before we run out of time, let me contrast that argument with this second argument here. No, first, let me first contrast this argument with the third argument here. This one: no one is Martian. Ghost is from planet Earth. Those are the premises. The conclusion, therefore, Ghost is Martian. So, one thing that we can conclude, that we can, I guess, see intuitively from this argument is that it's not clear how the person who's putting forth this argument, if someone is, it's not clear how they are concluding the conclusion, how they are inferring it from the premises. So notice that the premises says that no one is Martian. So Gauss, I mean, just from that, Gauss couldn't be Martian, right? Because no one is. But premise 2 just says Gauss is from Earth. So also there's absolutely no connection between the premises. So notice the difference between that argument and the one on all men are mortal. In the argument about all men are mortal, there's a very strong connection between the premises and the conclusion. The premises give you this information that lets you know that these two classes of things, the men and the mortal things, they are connected, and that Socrates is part of one of those. But Socrates is part of the one that's included in the other. So Socrates must be included in the other. So that connection between premises and conclusion, which guarantees the conclusion, that's logic, okay? And in this third argument, there's no connection at all between premises and conclusion. So what we say in that case is that it doesn't follow, as as people, if you want to be fancy, this is how you write it down. It's a non sequitur. It doesn't follow. The conclusion doesn't follow from the premises. So there's no question of its soundness. Because for an argument to be sound, the premises, not only must the argument be valid, but the premises must be true. And this argument isn't even valid because the truth of the premises doesn't guarantee the truth of the conclusion. If the premises are true, in fact, the conclusion can't be true because the premises are saying that no one is a Martian and the conclusion is saying that someone is a Martian. Okay? So I hope I'm not going too fast. We're going to revisit all of this, and it's in the handouts, but we're going to be looking at a ton of examples. And it's going to be also on the YouTube, right? I'm going to upload it to, you're going to be able to look at all of this by Moodle, so don't worry about that. So first argument, valid and sound. This argument about Gauss, neither valid nor sound. Third argument, what's the deal with our argument before we leave? That's the last exercise for today. Go ahead.
Would that be valid but unsound?
That's exactly right. Why do you think that's true?
It follows the exact same form as the first argument about Socrates, but it has untrue premises. So it has a valid form, but the premises are incorrect.
Yeah, that's exactly right. So we have, that's a good insight. So the argument looks actually, in terms of form, it looks exactly the same as the first one. So we have the cats here and the dogs here. And it says Ernesto is a cat. So let's put Ernesto here. So notice that if the premises were true, this is a way to represent what the premises will be saying. If they were true, then it will be the case that the world is such that there are these classes of things, the cats and the dogs. The cats are included in the dogs, and Ernesto is one of the cats. So since Ernesto is one of the cats and the cats are included in the dogs, it's going to follow that Ernesto is a dog. But again, that's under the supposition that the premises are true. If the premises are true, this is what they will represent. So if the premises were true, the conclusion will be guaranteed. It will be, so the argument is actually valid. It's logically valid. It's a good argument in that sense. And by that, all I mean is not that the argument actually establishes anything. No, all I mean is in the logical sense, it has the property we want, which is logical validity. If the premises were true, the conclusion will be true. But sadly, the premises are false. There are no cat dogs in this world. So it's not a sound argument. But this partly shows that you can have an argument which is valid, even if the premises are false. And that if an argument is invalid, as in this example, then if an argument is invalid, then it cannot even be sound in that case. So we're going to leave it here for now, but as I mentioned, there's a lecture that I owe you that I'll be uploading today, and you'll have plenty of time. As I mentioned, again, I must stress out, I think it's important to try and get the homeworks ready soon because it's fresh on your mind. And also, it lets me see how you're doing. But if you're a bit delayed or anything like that, it's not an issue. So we'll see each other next Friday. I'm going to be uploading that lecture to the Moodle today, later today, and also the exercises. And it was nice meeting you.
Thank you very much. Take care.
Thanks very much.
Thanks.
Thank you.
Bye-bye.
Thank you.
Thanks.